The coastal mountains of British Columbia are home to half of all the ice cover in western North America outside of Alaska. Ice cover that becomes life-giving moisture for the watersheds below. This area is the site of a dynamic interplay of life that has learned to roll with the radical mood swings of this rugged landscape. But climate change is affecting how and when water moves through the watershed, a dramatic shift that is felt by creatures large and small. At the Hakai Institute, we follow the flow of the water, studying its properties from the mountaintops to the streams, rivers, inlets, and throughout the coastal oceans. Our mission? To see how climate change threatens to disrupt the ecological clock of this incredible landscape. The mountains here are covered in a layer of ancient ice, accumulated over thousands of years as the mountains forced moisture out of the humid coastal air. Glimpses of meltwater can be seen through the snowpack as it escapes over the mountainsides, forming streams and rivers. This meltwater erodes sediments and transports essential nutrients. However, the glaciers in this area are shrinking rapidly, retreating due to climate change, so this source of life-giving water won't last forever. Early findings show that by the end of the century, glaciers in British Columbia's coast mountains will disappear by up to 75%. So it is critical that we understand these systems before it's too late. Our research in this area focuses on 3 coastal inlets, Toba, Butte, and Knight. Knight Inlet is a 125-kilometer gouge into the mainland that has been studied since the 1950s. Contributing to such a lengthy and detailed record allows us to see how a shifting climate is reshaping this landscape and the life that calls it home. On a reconnaissance trip in the summer of 2019, our watershed scientists take to the skies to understand how runoff contributes to inlet ecology.
So we're going to go to each of the major rivers that flows into this inlet and collect a water sample. And we want to get measurements of the chemistry of the river as tracers of fresh water.
By getting a chemical fingerprint for each watershed, we can gain insight into the inlet food web. These inlets are formed by glaciers that retreated at the end of the last ice age. They're a place where fresh water from the melting glaciers and rain-drenched valleys above meet the incoming ocean below. The murky glacial runoff extends for tens of kilometers. By contrast, smaller ice-free watersheds generate clear runoff that we can see entering these inlets like a dye mixing into a giant tank. As the fresh water makes its way to the mouth of the inlet, it's greeted by our oceanography team aboard a research vessel, instrumented to understand each inlet's unique circulation.
So as we're sailing through these fjords, you're surrounded by these really steep walls. And what you don't know is that below you, there's essentially a mountain range. You're actually sailing over these peaks and sills and troughs. And all of those features have a really big impact on the water.
The terrain of the inlet forces vigorous mixing near the sill and restricts water movement landward in the trough. This circulation shapes the life that can survive in these regions. To understand current conditions below the surface, we lower instruments like electronic CTDs that measure physical properties like temperature, salinity, oxygen, and depth. And Niskin bottles, which collect water samples from depth that inform us about the chemistry and microscopic biology of the inlet. And bongo nets sieve the water column for zooplankton, animals barely visible to the naked eye that are a crucial link between microscopic plants and larger animals like fish and whales. These samples, collected from the mountains, streams, and depths, will take months to fully analyze as we continue to monitor the region. Compared to those early expeditions, we already know that oxygen is decreasing and temperatures are rising in the inlet troughs. And there's so much more to be discovered. Life here is robust, but with climate change progressing with unprecedented speed, it threatens to fundamentally change the natural dynamics of these incredibly diverse ecosystems and the water they rely on.